Hey everybody, Matt Bradford here along with Sam McGowan, Senior Technical Marketing Managers for VMware's Cloud Management Business Unit, and welcome to MOAD 4.0, a Kubernetes story. This is just part one of a two-part demo, so be sure to check out both of these. Now, the reason we created this demo is to be able to show the full capabilities of the vRealize suite working together to help customers operationalize Kubernetes, rather than provide you with a series of deep dives that you would then have to stitch together. Now, of course, those are important too, as they dive a lot deeper into the full set of capabilities of each of the vRealize products. Now, this demonstration is set around the story of one company as they forge ahead with the adoption of Kubernetes. First, let's take a look at the capabilities of the vRealize suite, starting with the application operations and the programmable provisioning. This is where our IT consumers, our developers, our application teams can go for self-service provisioning of things like virtual machines, applications, or even Tanzu clusters. And this allows IT providers to ensure that these services are provisioned in a consistent manner and can be provisioned across clouds, whether it's the public cloud, the private cloud, or even VMware Cloud on AWS. And once they're provisioned, they can be managed through self-driving operations to ensure performance, compliance, and security. And let's take a look at the personas that are most impacted by these capabilities. You can see we have this split up into two categories, the consumers and the providers. So our cloud admin, our VI admin, our network admins, they're all responsible for providing that infrastructure, that platform, and that self-service catalog that can then be leveraged by our consumers, our developers, our SREs, who are there to deploy and to support the applications that serve the business and allow it to run. So let's take a look at these personas in context of the vRealize capabilities. So our cloud admins, they're responsible for the cloud strategy. Where do we want to run these workloads? And what workloads do we want to make available? And how do we govern these? So they're responsible not only for the strategy, but also making these services available through the catalog and making sure that they're compliant with that strategy. And then, of course, the VI admin and network admins, right? They're going to be taking care of things once these services are deployed to ensure that that platform is able to serve those applications, to make sure that they're performant and that they're not negatively impacting the business. So our story today takes place at a fictitious company called Massachusetts Omni Automated Devices, or MOAD for short. So for the last couple of decades, this Boston-based company has been building industrial robots for things like assembly lines and farm equipment. And they've also dabbled in things like AI and how can they leverage that to help make their robots more productive for their customers. And within the last couple of years, they've discovered this whole new market of toy robots and educational kits. And so in order to capitalize on this new market, they've rebranded themselves as moad.io and built out an entire e-commerce site so that consumers can purchase those kits directly from MOAD. So with these larger web presence, of course, they had to build out more infrastructure and they needed to support it somehow. So back in 2020, they purchased the vRealize suite to be able to manage that entire cloud infrastructure from the provisioning all the way to the day two operations. And so that takes us to the present day, where their e-commerce site has been a huge success and has generated a lot of revenue for MOAD. But just like any new venture, there have been a number of bumps along the way, which has caused MOAD to reevaluate their current cloud strategy. So today, they're rolling out their new Deploy Anywhere cloud strategy. Now this means they need to adopt Kubernetes, and in order to do that, they have to refactor their entire web front end to be able to run in containers. Now, of course, this is a heavy lift for MOAD's small team of developers. However, the payoff is that this will allow MOAD in the future to reevaluate their cloud options and, if necessary, redeploy their website to a different cloud much easier than they could with a monolithic type of application. Plus, they can scale out much more seamlessly when there's high demand on their website, such as when they run large sales. In order to facilitate this, their cloud admins had to automate the deployment of Tanzu Kubernetes clusters on vSphere, so that way their developers could request these and provision them on demand. And like any good cloud citizen, MOAD also has requirements around the management of day 2 operations for each of these clusters. So this meant they were required to also create automation to deploy Prometheus and the Telegraph Explorer into each cluster to be able to collect metrics. Plus, they need to be able to monitor all of this with vRealize operations. That way, their VI admins can get a complete picture from the container all the way down to the vSphere and physical infrastructure to identify if there are any issues or misconfigurations and to facilitate faster troubleshooting and time to resolution. So let's dive into the demonstration here to see how all this comes together.
Okay, so as part of the development team for MOAD, I'm actually going to need to request a new cluster, a new Kubernetes cluster for my development and test teams. So I'm going to go into my service broker catalog, where I've been presented a variety of options. One of them is the deploy TKG workload cluster request. So I'm going to come into the form and request a new cluster. Now, the project I want to deploy this is part of field demo. I'm going to enter a name for my cluster and a description. I'm going to select the MOAD management cluster, and then I actually want to create a larger cluster. So I'm going to select the large sized VMs, and you can see that it gives me the details of what the size of the VMs is going to be there. I'm going to enter an IP address that's been allocated for my API, so my Kubernetes API, and then I'm going to select a production or development sized cluster. And the difference between the two of these is whether we get a HA control plane or whether we get a single node control plane here. I'm also going to select the number of worker nodes that I want, and in this case the pre-populated 3 nodes is fine. And then finally I'm going to enter an IP range for my load balancer, and this is to allow me to have applications load balanced within the cluster. So I'm just going to create a small range with 5 IP addresses. And then I'm going to submit my request, and you can see that my deployment has begun. Now, switching hats slightly, as the cloud admin, I'm actually going to go into CodeStream and look at what's happening behind the scenes, because this request in Service Broker has requested the deployment of a CodeStream pipeline. So when we come into our CodeStream dashboard, we can see of the pipelines here, I have an execution running of the deploy TKG workload cluster pipeline, and if we actually click directly into this execution, we can see that there are a number of tasks within the build pipeline, and the tasks are completing in parallel and sequentially. In order to take a look at what's happening behind the scenes, we're actually going to go into the pipelines tab and open this pipeline itself so that we can have a look at the different stages that are available to us. Now we can see the same names for tasks and the build stage within this pipeline. And I'm going to select initially the workspace and have a look at the configuration of this. So we've got a Docker host configured. So this is a Docker endpoint which has been configured for me to execute my CI tasks on. And then I've got a specific builder image URL. So that's the Docker image URL that's available, and it's a specific TKG Docker image and a specific version. We can also configure things like the build directory within the CI containers, and also how much memory and CPU we want to allocate to the CI tasks. When we go to the inputs, we can see these are the inputs that we had for the form in Service Broker. We can see that we've entered the cluster IP, for example, which is the Kubernetes API IP. Whether it's a development or production environment, the number of nodes, all of those are reflected within the inputs of the pipeline. And moving back to the model stage, we can then have a look at, for example, this pipeline here. And basically this first block of activities is actually going out and grabbing information that we're going to need to build, and ensuring that we have the correct access and the correct tools that are available to us. So for example, this one is getting the Kubernetes config for the management cluster. and that's using a sub pipeline called get variable, which is making an API call to the variables within CodeStream and pulling out some information that we need. And we can see here that's based on the name of the management cluster. So the variable name is defined by the management cluster that we selected as an input. We also have a CI task here, which is performing an installation of the Tanzu Kubernetes Grid CLI tool. We're downloading our TKG CLI from my VMware itself. So we're actually grabbing some secret credentials, which are environment variables. We're then performing some command line actions, and we're actually just downloading that TKG CLI and also a Kubernetes CLI. The get VRA token is allowing us we're authenticating against VRA to get an access token that we can use later on. So all of these informations are requested, and once this stage completes, we move on to the deploy TKG cluster, and this is where we're actually using the TKG command line within a CI task. We're setting up some information, for example, the outputs of our TKG management cluster config and also the management cluster Kubernetes config. We're actually pulling out those configurations into YAML files. And then we are performing some setup tasks. And then we make a decision based on whether it's the production or development environment as to whether we're specifying the number of management VMs or just the worker VM count. And then we have this TKG create cluster command, which is actually starts to deploy our cluster in our vSphere environment. And you can see we've got, again, the inputs, the cluster name, we've got the config file, we've got the number, the type of plan, so whether development or production. We've also got the size of the VMs that we specified. And then also the cluster IP, which is the Kubernetes API IP address. Once we've done that, we get the credentials for this cluster, which allows us to create a service account for the integration with things like VROPs, and also integration back in with the platform later on. So we're actually creating a service account called vRealize integration, and we're creating a role binding to the cluster admin role for that. And then finally, we're exporting some information to allow us to configure endpoints later on. So the cluster address is exported, and this is exported as a property here. You can see down here, cluster address. So it's available to the pipeline afterwards. Similarly, we've got the cluster fingerprint, which is the SSL certificate fingerprint. And we're using an OpenSSL command to grab that. We're getting a token for authentication. And also we're getting the actual certificate authority data here, and that allows us to use it to create endpoints within the platform. Next up, we are configuring the load balancer, and this is using that IP range that we've been given. We're actually taking that IP range and creating a software load balancer on that cluster to allow us to have IP addresses for inbound application access. After that, we deploy some monitoring configuration, and this sub-pipeline is configuring Prometheus specifically for VROPs to access and begin monitoring this cluster. And what we'll actually do is, you can see we've got like the cluster address coming from previous task stages, and the cluster name, and also the token that we created for the vRealize integration account. And if we go and actually jump into the pipeline itself, the sub-pipeline, we can see we've got a CI task which performs some initial configuration to allow us to access Kubernetes. We then create things like a Docker registry secret to allow us to download images from Docker Hub. And then we create a monitoring namespace, and these are all kubectl commands. We're then downloading and applying some YAML files. So first of all, Telegraph policy to deploy Telegraph, and then also a Prometheus deployment to actually deploy our Prometheus pods for monitoring. And then after that, we are generating an IP address based on the load balancer. So our Prometheus instance, we're getting the IP address that's been allocated to that. And then finally, we're generating a JSON configuration file, which allows us to configure vRealize operations to connect to this instance of Prometheus. So this output, this VRops endpoint JSON, is then going to be put into this Kubernetes adapter pipeline, which is making a REST API call to vRealize operations with the payload that we generated in that initial stage, and we're actually just creating an endpoint. And if we look at the this pipeline itself, this is just a generic wrapper around a post REST request that's just specifically configured for using a vRops token. Okay, so once this pipeline completes, we should have Prometheus configured and monitoring in vRops. And then we've also got another couple of pipelines here, creating a Cloud Assembly endpoint, so configuring Cloud Assembly to talk to the Kubernetes cluster we've just deployed, and also to create a new endpoint that we can then target in pipelines for CodeStream to deploy to Kubernetes. Okay, so let's have a look at where our deployment has got up to now. We can see that our initial setup stage completed. We've got green ticks there. The deployment of our TKG cluster is actually completed, and we're moving on to the load balancer configuration and then the monitoring and endpoint configuration. So let's go and have a look in vSphere and see what's been deployed. Hopefully we can see here we've got our MOAD management control plane and a single node, and this is our TKG management cluster. And then below that we've got our MOAD test control plane, again a single node control plane because it's a development environment, and then our 3 worker nodes here. Okay, and now our load balancer is configured and our endpoints are configured. So hopefully, there we go, that's the pipeline configured completely. So let's go and have a look at the endpoints, and we should see MOAD test has now been added to our endpoint. And if we open this up, we can see that we're using a token-based authentication. This is the vRealize integration token that we created. And if we validate this, we can actually prove, yeah, the endpoint's validated successfully. We've got access to our Kubernetes cluster from CodeStream. And also let's go and have a look in Cloud Assembly, and we'll jump over to the infrastructure tab and then the Kubernetes tab. And within here we have an endpoint for Cloud Assembly to use. And this is the MOAD test. And if, for example, our developers want direct kubeconfig access, they can actually click on the kubeconfig and download our kubeconfig file. And you should see here we've got a standard kubeconfig. You could pipe into kubectl and execute your commands directly against it with the CLI. And with that, I'm going to hand you back to Matt, who's going to validate the vRops configuration.
All right, thanks, Sam. So let's take a look at this from the perspective of the VI admin. And so I'm going to launch vRealize operations here. And first, I'm going to show you the Kubernetes adapter that was created as part of this pipeline. So we deployed the Tanzu Kubernetes cluster, we deployed Prometheus in that cluster, and we also created the connection from vRealize operations to that Tanzu cluster so we can start to manage it. So first, let's go into the administration tab here, and under other accounts, this is where all of our Kubernetes accounts will show up. And you can see here MOAD test. So this adapter actually got the name of the Tanzu cluster that we just deployed. And of course, we gave it a description here. And then the URL. So this is actually used for vRealize operations to connect to the cluster and be able to discover all of the nodes and the namespaces, the pods, the containers, everything that's running within that Tanzu cluster. Now we're getting metrics through Prometheus. So through the collector service here, you can see we've got Prometheus selected. And then under the credentials is where we actually go and make that connection. So right here is the URL for the Prometheus server, which was, again, passed through when that pipeline created this Tanzu adapter. And of course, it gave us the bearer token and everything, so we can actually connect to the Kube API to be able to discover all of these objects. So that adapter looks pretty good. Let's go ahead and cancel out of here, and let's just validate and make sure that we are able to discover all of the Kubernetes objects. So I'm going to go here and search for Moad test, and we can see our Kubernetes adapter here. There's no alerts or anything, but this is brand new, so I wouldn't expect to see really anything here getting flagged just yet. So let's go into the metrics tab, and this gives us the relationship view of our cluster. So we've got our Moad test, this is our cluster here, and then these are all of our different nodes. So if I expand this out, we can see our control plane node and then the 3 worker nodes right within here. So that's looking pretty good. Then if we go into the monitoring namespace, this is where we deployed Prometheus. So I can expand this out. There's the Prometheus deployment here. Here's the Prometheus pod, and then finally the Prometheus container. So we'll let this sit for a little bit and start collecting metrics. Meanwhile, join us for part 2 of Moad 4.0, where we will actually go out and deploy the application. Now, if you want to get more information and see more of the vRealize suite, then check out pathfinder.vmware.com. Pathfinder will allow you to explore vRealize log insight, network insight, operations, and automation. And within each of these products are paths, which cover the core use cases. So for example, here in vRealize operations, we could dive deeper into Kubernetes management, or even look at intelligent remediation. Each of these paths will start with a level 100 overview and then dive deeper into 200 and 300 content, plus give you hands-on experience. So do check out pathfinder.vmware.com today. So with that, farewell until part 2. We'll see you over there. Thank you.